Hello. Today's notes are going to be about translations. It's going to be the first of a three-part series. So today we're going to talk about translations, and then in the following videos, we'll talk about reflections as well as dilations. So we are going to go through one. I need you guys to be able to identify. So let me get my pen there. I need you to be able to identify what the transformation is, and we're going to apply it to an equation, a point, and a graph. Okay, so one, I want to be able to identify what the transformation is, and then I want to be able to apply it to a point, equation, or graph. Okay, so we have this thing called transformational function form. Okay, and what it's basically saying, and you're used to vertex form with the h's and the k's. Okay, these values are going to be my transformations. They're going to be, in this case, where they're going to be my translations. Okay. Now, I want you to see where they're located. All right. When they are inside my parentheses, those are going to be horizontal. So when it's inside my parentheses, it is going to be a horizontal translation. Okay. Now, if I were to do the same thing on the outside of the parentheses, okay, then it's going to be a vertical translation. So that's the first thing I need you to understand is which one we're talking about here. So if you ever add or subtract a value to the inside of your function, that is going to shift your graph to the left or to the right. If you ever add or subtract to the outside of your function, that's going to move your graph up or down. Okay, so different where you add a value to your function is going to definitely have an effect on how your graph moves. So we're going to start with horizontals, then we're going to transition over to verticals, and then I'm going to combine them at the end. Okay, that's the goal here. So we're going to do horizontal, then we'll do vertical, and then we'll combine the two. So if you take a look, I just want you to see a problem with numbers in it. You can see this is what we're going to start with. Okay, we're going to take a look at what number is being added or subtracted to the inside of my function. And I have some functions that are a little bit more basic. So if you take a look, I want to talk about what the effect is when I add or subtract. So this is my basic quadratic function. Okay, from like the very first or second QPC that we took this year. That is the OG, the original quadratic function. Now, if you were to subtract 3 from the inside of that function, what that's going to do is rather than being at the origin, it's going to move it once, twice, 3 times to the right. So it's going to move it 3 units to the right. Okay? Now, likewise, for this last graph, if you add 3 to the inside, right, rather than being at the origin, you can see where my graph is located. It's going to move it once, twice, 3 times. So it's going to go 3 units to the left. Oops. Okay, so it's going to go 3 units to the left. So there's a very important note that you need to write down. And we're talking about the inside of the parentheses, right? So when you add or subtract to the inside, it's going to move it horizontally. And more specifically, when you add, it's going to go left. And when you subtract, it's going to go to the right. Okay? So if you add a value to the inside, it's going to shift my graph left. And if you subtract a value to the inside, that's going to move it to the right. Okay? So let me show you a few examples with that. So the first one I have, again, I subtract 9. So when you subtract to the inside, this is going to go right 9 units. Okay? Now, if you were to add 4 to the inside, that's going to go left 4 units. And I'm going to keep writing the same note over and over. Again, if you add to the inside, that's going to go to the left. And if you subtract, that's going to go to the right. Okay? So when we're dealing with horizontal translations, you can see these parentheses. This is important. So when you start adding or subtracting inside these parentheses, you're going to get a horizontal movement, right? So feel free, pause the video, and try to identify what is this transformation going to be, right? So if I subtract 12 from the inside, then I'm going to have a horizontal translation right 12 units. Okay. I got another one. Feel free to pause the video. Try to do this on your own. If I add 6 to the inside, that means I'm going to have a horizontal translation left 6 units. Okay. All right. So now I want to apply this to a table of values. Okay. So first thing that we need to do is if I go from the basic, the original quadratic, to this second function over here, I want to first identify what is the transformation that's taking place, right? So if I go from x squared to x minus 4 squared, I know I am going to shift my graph right 4 units. Okay? Now, if you shift your graph 4 units to the right, all right, what I'm going to end up doing is I'm going to increase the value of all of these x values by a value of 4. So I'm going to add 4 to all of the x values. Negative 2 plus 4 gives me 2. Negative 1 plus 4 gives me 3. 0 plus 4 is 4. 1 plus 4 is 5. And 2 plus 4 is 6. Now, because all I'm doing is moving this graph to the right, it's not going up or down. So it makes sense that the y values are going to stay the same. This is still going to be 1, 4, 1, 0, 1, 4. Those don't change. And this would be my new table of values. Okay? Now, let's do it again, just so you can see. First, we want to identify what is the transformation that's taking place. So if I go from x squared to x plus 2 squared, this is going to move left 2 units. Okay? Now, if I move left 2 units, I want to shift all the x values 2 units left. So I'm going to subtract 2 from all the x values. So my new x values, negative 2 minus 2 is a negative 4. Negative 1 minus 2 is a negative 3. 0 minus 2 is a negative 2. 1 minus 2 is a negative 1. And 2 minus 2 is 0. Now again, all we did was move our x values to the left. This graph isn't going up or down. It's just moving left 2 units. So stay at the same height. So all my y values need to stay at the same location. And this is my completed table of values. All right. So what I want to do is I want to go through the same steps, but this time for vertical translation. So quick summary. And I like to use this slide for my summary. Remember, if it's addition, right, we're going to go left. Okay, our graph would move left. And if it's subtraction, we know our graph would move to the right. Okay, so if you subtract 9 on the inside, it goes right 9 units. And if you add 4 to the inside, it would go left 4 units. Now, vertical translations have different rules. Okay, so vertical translations are on the outside or after we squared x, right? They're after it. They're in addition to it. So if you add 3 to the outside, it's no longer in the parentheses. My graph is no longer going to be at the origin, but it is going to go up 3. Notice we do not take in the opposite anymore. If you add 3, you go up 3. If you subtract 3 to the outside, that means we're going to go down 3 units. Okay? So whatever you add or subtract to the end of your function is going to move my graph up or down. Right? So let's take a look at some examples. So if you add 4 to the outside, that is going to make it go up 4 units. If you subtract 20, then it's going to go down 20 units. So when we're dealing with vertical translations, again, these are on the outside of the parentheses or not in parentheses at all, right? If you add, it's going to go up. If you subtract, it's going to go down. Okay, so that's how I know which direction it's going to go. So let's take a look. Pause. Try to do this one on your own. But here, I add 14 to the end, and I know it has to go up 14 units. If I subtract 7 from the end, I know it has to go down 7 units. Okay, so that's how I'm going to move this graph around. So again, we're identifying what the transformation is, but now can we actually apply it to a table of values, right? So if I go from x squared to x squared minus 1, I know my graph is going to have to go down 1 unit. Well, if I go down 1, the x values no longer change. It's the y values that are going to change. So if I go down 1 unit, I'm going to subtract 1 from all of the y values, which would make this y value 3, 0, -1, 0, 3. So I subtracted 1 from each of the original y values. Now, because I'm just moving it down, all the x values stay the same. Makes sense, right? If you think about it, if you move something down, it's not going to move left or right at all. It just moves down. So all the x's stay the same. So now I also included a little coordinate plane here because if we wanted to graph that, take a look at what it looks like. -2, 3. -1, 0. 0, -1. 1, 0. And 2, 3. I get a graph that looks like this. Now, the original, the OG of quadratics, I'm going to graph in red, goes through the origin. Get my pen working here. There we go. Okay. And it looks a little something like this. So you can see the similarities. They're the same graph. The purple one is just shifted 1 unit down, 1 unit lower than the red graph, which is the idea, right? Isn't that the translation? So 1, we can identify what that translation is, but then 2, we can actually apply it to a table of values or a graph. We can take all those points and move them down that many units. So let's take a look at this one. Feel free to pause. You could try to do this one on your own. All right. If I go from x squared to x squared plus 4, that is going to go up 4 units. So I'm going to take all these y values and I'm going to add 4. So 4 plus 4 is 8. 1 plus 4 is 5. 0 plus 4 is 4. 1 plus 4 is 5. And 4 plus 4 is 8. Now, because we just moved up 4, we didn't change any of the horizontal values. So all of those x coordinates are going to stay exactly the same. Remember, if you move something vertically, the y's change. If you move something horizontally, the x's would change. In this case, we just moved it up 4. So that's why we only changed the y values. Okay? So now if I plot these points at -2, 8, at -1, 5, 0, 4, 1, 5, and 2, 8, you can get a picture of what this looks like. Now remember, the OG, the original quadratic, goes through the origin, right? So the original looks a little something like this. You can see the purple graph is just shifted up 4 units. So for all the visual learners out there, you can see it. If you look at that graph, you can see the red graph just moved up 4 units to give me the purple graph. So all those points, just move them up 4 boxes. Okay, so let's try to piece together some ideas. So again, I want you to recall, if I add to the inside, this is a horizontal translation left 6, because remember, we do the opposite. If you subtract 7 to the outside, that's going to be a vertical translation down 7. Okay. So you can see both of them in the same problem. You have a horizontal movement and a vertical movement. All right. Try to pause. Try to do this one on your own. Okay. What are the 2 transformations in this problem? Well, if you subtract 25, that means I'm going to have a horizontal translation right 25, and this 8 would be a vertical translation up 8, because it was a plus, so that means it's going to go up. So we have 2 transformations, right 25 and up 8. So let's apply both of these transformations to a table, right? So if you look at this, if I go from the basic to this function, I know I need to go right 4, and I need to go up 2. Well, if I go to the right 4, that means I want to add 4 to all of these x values. So -2 plus 4 is 2. -1 plus 4 is 3. 0 plus 4 is 4. 1 plus 4 is 5. 2 plus 4 is 6. But now I want to shift everything up 2, which means I'm going to take the y values and I'm going to add 2 to them, right? So the horizontal movement goes to the x's. The vertical movement goes to the y's. So 4 plus 2 is 6. 1 plus 2 is 3. 0 plus 2 is 2. 1 plus 2 is 3. And 4 plus 2 is 6. So now if you want a graph of this, I can plot these points: 2, 6, 3, 3, 4, 2, 5, 3, and 6, 6. And that is my graph. Okay? All right. So today we talked about translations. We not only identified them, but we applied them to a table of values in a graph. Next video, we will talk about reflections as well as review translations. Okay, hopefully this video helps. Have a wonderful